give a little heads up that if you're interested or you're coming or planning to attend more of the Healthy Brain seminars this semester, we have 2 more, one in April and one in May. They will both be over here. We found that we ended up with crowding issues when we were across the way, so we're going to move them back over here. Just kind of a heads up. So I'm Florence Breslin. I am the Child and Adolescent Clinical Manager at LIBR, which means that I run the child and adolescent research programs that we do over there. Part of that job, and pretty much my main job, is to be the coordinator for the Adolescent Brain Cognitive Development study. This study is a nationwide study. It's funded by the National Institutes of Health, primarily NIDA, the National Institute of Drug Abuse, and NIMH, the National Institutes of Mental Health. Those are the 2 main focuses of our research program, are the effects of drug and alcohol and the effects of mental health. That study is done at 21 sites throughout the country, enrolling 12,000 kids. So it's a very big undertaking, and a lot of what we're talking about here and kind of some of the questions that are still there, we're hoping to address with the ABCD study. First thing I want to do, especially since they're still out in the hall, is give a shout out and a thank you to all of my RAs. They run the research program, but they're effective. They are the team that runs this. They set up, they bring the snacks, they take your information, they give you everything you need. They do all the work for Healthy Brains so that we can have these talks and kind of give back to the community. So I do want to give them a special thank you, especially Colin. If you heard about this study, it's because Colin sent out something. He's definitely the person in charge of recruitment for us and getting it out to everyone. And if you have somewhere that you think it should be advertised or you want to share it, he's also the person out there you should talk to, because we're more than happy to share with other groups if they're interested. Okay, so why are we here tonight? We're here tonight to talk about drugs of abuse in teenagers. We have a big group of teenagers here. This talk was kind of derived for parents to talk to their teenagers, but there's definitely a lot you can take home from it and talk to your parents about. But my goal here is to kind of get around 2 phenomena. The not my child, so my child would never do that. And I come from a place of studying addiction. I've been in the field of addiction for many, many years, more than I realized when I started looking back at it today. But also as a parent. I have 2 children. I have 2 boys, a 6-year-old. He's my favorite after doing this PowerPoint together because he has several years before we get to this point with him, because I then have an 11-year-old, and he is right on the cusp of these different principles that are coming up, dealing with alcohol and drugs and making sure that they know that, yes, we know it's a problem. Yes, we know that there are teens using drugs and alcohol, and that may not be the best thing for them. But I also want to get very far away from the because I said so rule. I am a mom. I have definitely said because I said so. But we know that that's not super effective, particularly to teenagers. And I don't think it's the best way to convince somebody that's doing something might be harmful to them. I think it's much more valuable for you guys to know and for parents to go home to their kids and say, look, it's not just that I'm not cool or that I don't want you to have fun with your friends. This is what happens to your brain, particularly your brain, because that's where my focus is going to be, if you use drugs, if you drink alcohol when you're still developing. And you are still developing. So you need to know this information, you need to be aware of what's happening so that you can make good decisions. And we're also going to talk a whole bunch about how the brain develops and why, because the effect of drugs and alcohol is different for teenagers than it is for adults, because their brains are still developing. So it causes different problems that are much more long-term because the brain is still developing. So we'll talk about how the brain develops and how these kind of things interact as well. Okay, so not my child. I hear this all the time from parents. Come in, my child doesn't know about drugs and alcohol. My child would never use drugs and alcohol. I will tell you that those parents frequently are the ones whose child have at least tried it. Now, 9 and 10-year-olds, not so much, but definitely the teenagers. And it is some of our kids. We all know that there are stats. Oklahoma is not doing super great. It's not as bad as you would think, but there is a prevalence here and everywhere in this country. So 18.5% of high school seniors or high schoolers have smoked in the past 30 days. And this was from 2015, so the last time I looked at it. 20%, roughly, have smoked in the last 30 days. And this is more than a puff. So it's not like they puffed off somebody else's. It's not a sampling. They smoked a cigarette. That's a pretty big number considering they shouldn't be doing it at all. Bigger 68.3% of students in grades 9 through 12 have had at least one drink of alcohol. So this is not sipping mom or dad's drink at home, or even having, mom's having a beer or dad's having a glass of wine and taking, having a little bit of it with them, especially the older kids. This is having a drink themselves. In 2011, 10% of Oklahoma 12th graders met criteria for drug or alcohol treatment. Means that they're using enough that they meet criteria to be treated if they sought treatment. So this is not just a once and a twice thing. 10% of our 12th graders need treatment for drug or alcohol abuse. There is hope. It is getting better. So the Monitoring the Future, which I'll talk about at the very end, I'll kind of give you some information, comes out from NIDA. It tells us how teens are using drugs. And it's getting better. The rates of teen use are coming down. A lot of people think that has to do with the fact the conversation is more prevalent. That happens to come in coincide with it being in the news more. We're talking about legalizing drugs in different states. We're talking, and here in Oklahoma, we're talking about the accessibility of alcohol, right? It was just on our ballot. So the kids heard about it in the news. It was much more likely to be a conversation. NIDA contributes some of the decrease to a little bit more prevalence in the conversation about drugs and alcohol. But it is coming down, except for marijuana. That's pretty flat. It's not going up, which everyone thought it was going to happen. At this point, it's not going up. But it's not going down either. Okay. There we go. So these are some stats comparing Oklahoma to the US. And this is the one that's probably the most concerning here in Oklahoma. Part of that may be the laws here are a little bit different than other parts of the country where there are much stricter tobacco laws, where you can smoke, where you can't smoke, things like that. But 50% of 9 through 12th graders have tried smoking, compared to 45%. So it's not a huge increase, but it's definitely higher. What bothers me a little bit as a parent is that it's this difference in trying to quit. There's less kids here in Oklahoma who are trying to quit smoking that are smoking. So it's not quite as taboo here. It's not something that we need to try to get rid of as much. These are not huge differences, but if you think about these percentages, if we take our group of teens back here and have all, I think about 8 of them stand up, 4 of them have used tobacco. That not necessarily that you guys have actually used it, but in that kind of percentage. That's a big number. And we need to be aware of it, and we need to be thinking about that. Okay. Obviously, we have a significant increase rate of chewing tobacco and things like that. It's much more prevalent in this part of the country than other parts of the country. This is probably the biggest difference is the males here. Any kind of tobacco is not really good for our purposes. We're talking about the brain. So this is not better or worse. There was a lot of comments when this came out. They're like, this is better because it doesn't have all the health risks of tobacco, right? The lung cancer, all the different problems we think. That's not necessarily true because tobacco, or nicotine, particularly the drug in tobacco, is affecting your brain no matter how you're getting it. So for our purposes tonight, it's important to remember that this may not be healthier for our purposes. I don't think it's healthier anyway. There are lots of health side effects of chewing tobacco anyway. But for our purposes, the nicotine getting into your body is what's important. Okay, we're not really different on alcohol. It's pretty similar to the rest of the country. So it's not as bad as some people say that, the drugs and alcohol are totally out of control here. There is an increase in certain populations. It's just not as prevalent in the teenage years. And alcohol, you also see in marijuana. We're a little bit under. Part of this is probably contributing to the fact that there are states. No, this is 2011. This is prior to the legalization of recreational marijuana in any state. So this is kind of just where the national statistics are. This probably will change a little bit, but we don't know that yet. We don't know how accessibility changes these rates in teens because it's not accessible to teens. You still can't go buy it because you're a teenager, just like alcohol and tobacco. It's still not legal for them. They couldn't go in and buy it and obtain it themselves. They would have to get it from somebody. Okay, these are kind of just the other outliers. The only thing I don't like is that they don't include methamphetamine, which tends to have a higher population here in adults, but we don't have the teen numbers for it. The difference in the country, the the statistics between Oklahoma and the rest of the country for amphetamines. But you can see we're not really different. And there will be citations for where all this data comes from. Most of these that aren't the actual literature papers, scientists doing experiments, are publicly available. So once they're recording the slide presentation tonight, it'll be available on our YouTube channel. So if you want to go and pull out these links and go and look at these, most of these are publicly available things that you can get online. They're public reports. And all the citations for them are in there. This, I think, is interesting. This is the National Survey on Drug Use and Health from 2013. And it's just interesting because it shows that we really are talking about a different population. So what this is the most abused substance by age group. So alcohol is most abused by older adults, older than 26. Whereas the teens and the 18 to 25s, and we'll talk about why I consider that still adolescence in a little bit, it's more marijuana. You can see this 18 to 25 group, it's a little bit higher in prescription drugs. That's because they can get them themselves now. They can get prescriptions, they can get access to them a little bit easier, so they tend to have a little higher percentage right there. But it's just kind of some interesting data about where drug use is and how it differs as you get older. Okay, so not my child. Well, maybe it is our children, and we need to be aware of that. We need to be aware that maybe it's our friends, that there are people using and that the conversation is important. Okay, so now we're going to talk about because I said so. So instead of because I said so, let's talk about what happens to the brain, how it's developing, and how drugs and alcohol affect it. Because it's much easier to make a decision once you know what's exactly happening in your brain than just because mom said so, dad said I shouldn't use drugs. It's traditionally not the best method of getting kids to listen to us. Okay, so we're going to talk about brain development in two primary areas of brain development, which is the prefrontal cortex and the limbic system. And what we're going to discuss is essentially that during adolescence, there's a heightened sensitivity to reward without full development of essentially our braking region, the self-control, the prefrontal cortex area of the brain. So the reward system comes on first, and then the control system comes online, and develops in that kind of staggered way. Okay, so this, I think, is a great little slide because we talk about adolescence in general conversation is 10, 12, 13, the teenage years, 13 to 18, when they become adults. Sexual maturation matches that pretty closely. That's where it kind of comes from. But brain maturation does not. The brain continues to develop well into the 20s and really is about 25 to 26. Girls, it's a little bit later. Boys, it's a little bit early. Or girls, it's a little bit earlier. Boys, it's a little bit later. But the brain is still developing. So for purposes of what we're talking about, it's important to know that your brain is still developing. Your brain is still in adolescence, well past maybe when you're at home, maybe when you're still thinking, I'm not a grown-up yet. Or I'm a grown-up, I'm not at home, I have a job, I live at a dorm, I take care of myself. Your brain may not be there yet. And I left the rodent part of this slide up because some of the data I'm going to present comes from rodents. And it's the same kind of thing. We correlate this part of the rodent life cycle to typical teen adolescence. Okay. So this slide is from the last talk. So you've seen it a couple of times now. It's the same slide, it's the same point. The brain develops back to front. So we get physical coordination, sensory processing, motivation and reward, emotions and impulsivity, and then we get judgment in the executive control centers. So this is your gas pedal developing before your brakes. It's Amanda Morris's coined phrase that I love because I think it's important. It really relates to parents. As a parent, when she said that, I was like, that makes a lot of sense. When I look at what my kids are doing, they've got a lot of gas and they don't have very many brakes. And it also makes it easier to talk to especially younger children. They can understand that concept. So we're going to talk about the systems in order that they develop. The limbic system is essentially responsible for emotion control and reward. There are lots of components. The hypothalamus does internal regulation. The cerebellum is responsible for balance and coordination. The hippocampus is responsible for learning and memory. The brainstem is the source of life. When we teach this to the 3rd and 4th graders, we tell them the brainstem is what you need to be alive. It does your heart rate, your sympathetic nervous system, breathing, things like that. It's what's keeping you alive. the pituitary gland, which is responsible for growth and metabolism, and the amygdala, which is your emotional regulation system. Okay, then we have the prefrontal cortex, which is the front of the brain. It's kind of this area here, and it's our executive function. It's a source of our executive function. This is the part of the brain that makes us different from non-human primates. We have the largest prefrontal cortex of any mammal, of any animal. It is where we get those differences. We can make rational decisions. We can consider consequences. We regulate emotional responses. Animals in the wild don't need to think about the consequences of their action. They need to run if the lion is chasing them and chase, whatever the smaller predator they're going after is. There's not a lot of this kind of executive functioning. This is what makes us very different in our brain. Okay, so what's the brain made up of? The brain is made up of neurons. This is my fun cartoon of a neuron. I'm going to stand over here. It's easier for me to point. So a neuron has one-way direction. Information comes in at the dendrites. It's processed in the cell body. It travels down the axon to the axon terminals where it sends information to the next cell. The myelin sheathing is a fatty coating that protects the axon. It is analogous to the plastic that's over like your phone cord. It protects the signal. It helps it travel faster. It is white in color, and that is interesting because it is what makes up the different parts of the brain. So in the brain, we have gray matter and white matter. Gray matter are the cell bodies, the dendrites, the axon terminals are in the gray matter. This is where signaling is happening between individual cells. The white matter of your brain are the neuron tracks. So they're the tracks of the axon covered in myelin sheathing. That's what makes it white. So the white fatty tissue makes that part of the brain look white. It's the tracks where they're going from one part of the brain to the other. Now, obviously, neurons are very, very small, but that doesn't mean they're short. There's neurons that travel from your eyes to all the way to the back of your optic nerve. The optic nerve travels from your eyes to the very back of the brain to the optic center. So they can be very long projections going all over the brain, but that's kind of the different components of how the brain's put together. All right. So how does the brain communicate? People communicate via talking. So do neurons. It's kind of like their little own form of conversation. There is a gap between each individual neuron. It is not a direct connection. It is not a direct electrical signal. The electrical component of neuron transmission is in any one individual neuron. It produces or releases a chemical transition that is what is used to signal the next cell. So these chemicals are what's transmitting information from one neuron to another. Those are called neurotransmitters. Serotonin and dopamine are two neurotransmitters. This is my favorite cartoon from when I was in grad school. Serotonin and dopamine are technically the only two things you enjoy. So we think about I really like fuzzy blankets. I don't really love heels, but I like, my slip-on soft shoes. I really like a nice warm bath. I don't actually like those things. They don't really feel that good to me. What I do like is the release of dopamine and serotonin that they cause in my brain. And I think that this is actually pretty important to think about when we're talking about this with teens, is that a lot of times we use drugs and alcohol to feel better. I even say it. I'm like, oh, it's been a long day. When I finish this talk, I'm going to go have a beer. It helps me relax. It helps me feel better. But it's actually changing the reception of these neurotransmitters. It's changing how my brain is functioning. And when you're thinking about how the brain works and how drugs and alcohol really affect us, how they affect us, it impairs your ability to drive a car, things like that. But it also is affecting how your brain is transmitting. So there's something really going on. And I think that that's the part of the conversation that's frequently overlooked when we talk about it. And a lot of times it's because we don't know. So goal here is to learn that this is what's going on in the brain, so that when we talk about it, we're talking about real things that are happening, rather than just, Mom, it feels good. Yeah, well, I don't want you to do that. Okay, so how do drugs work in the brain? Drugs affect the reward circuit, which is part of the limbic system. The reward circuit is primarily focused with dopamine. Serotonin is part of that, but it's primarily dopamine communication. Dopamine signaling is what causes you to feel good. Drugs do primarily two things. They either mimic dopamine so that your brain thinks that there's more dopamine being released, or they prevent your brain from cleaning up the excess dopamine so that there's a constant signal. This is a really old video that I used in my graduate school talks, but I think it's a good explanation of exactly how the process works.
Cocaine acts on neurons that release a specific neurotransmitter called dopamine. Normally, dopamine-containing neurons, like other neurons, communicate using electrical signals and chemical messages. When the presynaptic neuron is stimulated, the action potential travels along the axon to the axon terminal. This triggers the release of dopamine from the neuron into the synaptic space. The dopamine then binds to dopamine receptors on the postsynaptic neuron and triggers an action potential in that neuron. Dopamine then releases from the receptor into the synaptic space, where it is then degraded by enzymes or is carried back into the presynaptic neuron through transporters. When cocaine is present in the brain, it blocks the transporter proteins that normally carry dopamine back into the presynaptic axon terminal. This causes the amount of dopamine to build up in the synaptic space. The excess dopamine will continue to bind to receptors and stimulate the postsynaptic neuron. Cocaine really does change the way neurons communicate.
Okay, so I really do love that video because it kind of shows what's going on in the brain. So cocaine happens to bind to dopamine neurotransmitter reuptake proteins. Alcohol, nicotine can act like dopamine. They can essentially fool the dopamine receptors on the next neuron to think that there's more dopamine there than there is. So either way, what we have is a constant stimulation of the next neuron. Now, the brain is not a single unit train going this way. There's lots of feedback loops. And what tends to happen is that once you have increased transmission, it then signals back and says, oh, we still got transmission, things are still going on. We need to tell them to increase their signaling so that we can fight off whatever is going on. You know, maybe we think there's a bear around, or different evolutionary things. This feels really, really good, so we should keep doing it, things like that. So it then triggers the brain to start the process over again, increasing even more dopamine. So you get more and more and more dopamine. Now, what eventually happens is that the neurons can't keep that up forever. They can't just keep going like that. So what starts to happen is there start to be like, I see dopamine, but I can't respond to it. There's always dopamine coming in. I'm always getting a signal. I can't be firing all the time, so I'm just not firing until I have enough dopamine to fire. So then what happens is it actually takes more drug and more dopamine stimulation to get the same effect. And you'll hear this from people who are recovering addicts a lot. Once you become an addict, you don't take drugs anymore to feel good. You take drugs to stop feeling bad, and that's because the dopamine signaling system has essentially met a tolerance. So that they now need the drug because whatever used to make them feel good, snuggly blankets make me feel good. So I would put a blanket on and I would feel good and I would relax. Well, now that I've been using drugs long enough and my dopamine system is altered, I put on that snuggly blanket. It doesn't make me feel good anymore. Now I have to put on 5 snuggly blankets because I need more signal to tell me to be able to feel the same way. And what happens is in your everyday life, things that normally make you feel okay, help you from not feeling bad all the time, can't, because they can't keep up with the effect of the drug that was in your system. So now you have to take drugs, or you feel like you have to take drugs to continue to feel okay, rather than feeling good. Okay, so what have we learned about alcohol and drugs from the adolescent brain? I have 5 papers that I kind of like. Some of them are classic, some are newer, that I'm going to present some of the data from. We're not going to go through any one study, because I want to give you little snippets about the different common drugs and what we know from the research. We are just at the beginning of this field of research. Part of that is our inability to study it. So, like I said, we're going to have at least one rat study in here. Turns out you can't have parents sign up and tell them, we're going to do a trial where we're going to give 50 kids cocaine. We're going to not give 50 kids cocaine because we want to see what happens to their brain if they've never had cocaine and we give them cocaine. That's not a good study. Most people won't sign up for it. It's also not ethical. You can't do those kind of research questions. We can't answer this the way we answer research questions for a lot of things because it's a drug of abuse and it's addictive. So it's not like if I gave it to you once that you could just never use it again. The risk of you liking it is too high, and the risk of you becoming addicted and needing it are too high. So we can't do those kind of studies. The way you do drug and alcohol research is you look at people who already use, or you do observational studies of people who are using versus people who are not using. So there's a lot of questions that remain unanswered, and I'll kind of bring a couple of them up as we go through some of this data. ABCD, which is, of course, my study of choice at the moment, was designed to answer some of these questions. It was designed to bring children in at 9 and 10 before the onset of drugs. So one of the criteria to be in the study is the kids can't have drug abuse issues already. There's not a whole lot of kids at 9 and 10 that do, but there are some. So they aren't eligible for the study because we need a baseline. We need to know what the kids are like, what their brain looks like, what their behaviors will look like, their cognitive functioning before they come. And the reason it's a 12,000 kids study is because not all the kids will use drugs, which is a good thing. But we need enough kids at the end who have used drugs on their own without any indication from us, because we certainly don't tell these kids to go use drugs so we can see what happens to their brain. If no one in the study used drugs, that would not be it wouldn't help the data, but we are not encouraging kids in any way to use drugs or alcohol. But a good percentage of them will, right? 68% of them, once they get to 9 to 12th grade, will have at least had a drink of alcohol. So we can use this study, which is looking at a lot of things, not just drug abuse, but we can use it to answer some of these questions. Did these kids have differences in their brains before they used drugs, or did the drugs cause the difference? You know, it's a very chicken and the egg kind of story. Also, if the kids use and then they stop using, does it go back? Because it's a little bit more likely if you're doing a study like this where you're following to be able to get them back to see what happens after they stop. It's really hard to enroll people who use drugs or alcohol, and Susan Taper at UC San Diego, who is a PI on the ABCD study, does some of this research. She brought in adolescents and tried to get them to go 28 days without using marijuana. And they were pretty heavy users of marijuana. And a huge portion of them couldn't do it. They couldn't make it 28 days without using. So it's a really hard study to do. So hopefully one of the goals is ABCD is hoping that there will be at least a measurable percentage of kids who use at some point during the study who also then stop using naturally without intervention, without forcing from the study. Okay, so the first paper we're going to talk about is the influence of substance use on adolescent brain development. This is a comparison of prefrontal cortex volume in 16 to 24-year-olds. So like I said, adolescence, when we're talking about the brain, is not just, till you're 18. We really do consider ages up to about 24, 25, where the brain is fully maturing. There's a comparison here between heavy drinkers. So this is 16 to 24-year-olds that are having 4 to 5 drinks in any one day. So not necessarily that they're drinking 4 to 5 drinks a day, but when they drink, they're drinking 4 to 5 drinks in a day. And like to non-drinkers, which is less than 1 drink per month. So it's kind of doing 2 separate groups with everybody in the middle is removed. So you have the extremes. Because doing comparisons like this are very hard because everyone's got a little bit of difference anyway. So you need to have the extremes so you can see group differences. Okay, so what do we see? This is the part of the prefrontal cortex. It's the left ventricle. And what you see here, very nicely and cleanly, is that heavy drinkers, so that group of kids, teenagers, adolescents, 16 to 24, that are drinking regularly, have decreased cortical volume. Now remember, this is the prefrontal cortex. So what we talked about was this is the part of the brain that's responsible for regulation. It's the executive control center. It's where you're going to get your responsibility, consequence, decrease in risk-taking. The area of the brain that helps you regulate yourself is now smaller because of the level of drinking. So you're actually losing brain tissue. There's another paper in 2010 that didn't have a pretty picture, so it didn't make it in, where they actually looked at this phenomenon. And for alcohol particularly, there's an inflammation response that's killing neurons in the prefrontal cortex specifically, more so than other parts of the brain. So there's actual neuronal death that's happening here that's producing essentially this reduction in cortical volume. But if you think about it, when you're doing heavy drinking, so this is binge drinking. So this is, maybe you don't drink all the time, maybe you only drink once a month, but you go to a party and you're drinking 4 or 5 drinks a month at a time. This is the response from that. You're losing volume of your brain. And this is something that's predominant in the adolescent period. It is not as predominant once you become an adult. Not that you should be drinking that much as an adult either, because there are effects of that in your brain. But it's more prominent in adolescence because this is the part of the brain that is still developing through this age. So it's affected more because you're in adolescence, because the brain is still developing at that time. Okay, so the next paper we're going to talk about is neurocognitive functioning of adolescents, effects of protracted alcohol use. So big fancy title, if you're essentially to say they looked at subjects 15 to 16 years old, so these are a little bit the younger end from the last paper. These are alcohol-dependent teens. So they have 15 to 16-year-olds who are in a treatment facility for alcohol addiction. They recruited them from the treatment facility. Now, they had to be 3 weeks sober before they could do the testing. So they didn't want to test people who are either within withdrawal, because the withdrawal process, if you go through withdrawal, there's a lot of changes in the brain that are happening as your body's trying to essentially adjust back, or when people are on drugs. You don't want to ever do any testing or cognitive reasoning with somebody under the influence, because you're not getting a true response of their abilities. You're getting essentially the response of the effect of the alcohol or the drug. So they matched comparison teens who had no history of drug or alcohol use. So they matched them on things like age, gender, race, ethnicity. They also, very importantly, matched them on family history. So if you had a family member who had alcohol or drug addiction, the kids were matched on that, because there is a little bit of exposure differences and things in there's genetic components of addiction, so they wanted to make sure to account for that in this type of study. And then they did a battery of neurocognitive testing. It's about 10 or 12 neurocognitive assessments. And they put together essentially what they call nonverbal information coding and verbal information coding. So how well can you code information, verbal information? So how well can you listen to this lecture and take home the information? And then nonverbal written, spatial reasoning, so pictures, being able to work with numbers or sizes, things like that. And essentially what you can see here, which is pretty prominent, is those who are alcohol dependent have less ability to retain information, because this is retention rate. So how well can they retain the information compared to those who don't have a history of alcohol use? So not only is alcohol affecting the volume and the actual neurons, but that has an effect in abilities. So you're seeing a decrease in function and a decrease in structure or structural changes. So the brain is changing, but that's causing an effect. It's causing an effect on how well you can think, you can reason, you can learn. And of course, during adolescence is a big time of learning. That's why you go to school then. You can learn a lot. You can retain a lot of information. You're affecting that by using drugs. So now we'll move on to nicotine. This is actually from a rat paper. They pre-treated rats in early adolescence with nicotine. So this is what I was talking about. We can't do this in humans. We can't have a bunch of people bring in their 10 and 12-year-olds and be like, we're going to give them low doses of nicotine for like a month or two, and then we'll see what happens as they get older. You can't do those studies. So we do them in the rat to the best of our ability, and there's a lot of correlation between the rat and people. There's a lot of correlation when you look at, I studied rats of addiction for a very long time. I gave rats cocaine and we watched how they responded. We actually treated them with drugs to try to prevent addiction and to see how it affected their craving of the drugs. And we used those. They were what we called preclinical trials. So they were the clinical trials we did in rats to see if it would work, to see if it was effective, to look for, if the drug killed every rat. That wasn't something we were going to try out in humans. So we did a lot of those studies, and a lot of those drugs are things that they are using and working on still today in clinical trials now in humans to say, all right, this worked in the rat. We saw reductions in craving. We saw reductions in some of the neurological phenomena and disruptions that are caused by the drug. So now we'll try them out in humans and see if we can use them to help people who are addicted. So these are not silly studies. Doing this kind of research in rats does not pertain to us. We can get a lot of information about people from them. Okay, so what do we learn from our good friend, the adolescent rat? So this part is just essentially dopamine-mediated behaviors. They gave a stimulant that increases locomotion and penile erection, and they see an increase. So when they give this stimulant to essentially force the behavior, so we don't just have to sit around and count how the rat does it normally, because we can do things like that in the rat, you see an increase in response. This is the dopamine 2 receptor, and this is serotonin. So we see an increase in the behaviors that are regulated through dopamine and serotonin in animals that were pre-treated with nicotine. So adolescents get nicotine exposure, and then we see increases in how their body responds to dopamine and serotonin-driven behaviors. Okay? So reward behaviors. Rats pre-treated with nicotine, so they have this kind of nicotine, had enhanced acquisition of cocaine self-administration, methamphetamine self-administration, alcohol self-administration, and an induced cocaine locomotor sensitization. So this is interesting. I always heard when I was a kid, marijuana was a gateway drug. It was a gateway drug. If you used marijuana, you were going to use cocaine and heroin. Marijuana was the gateway drug, especially back in like the 80s and the 90s, because marijuana wasn't legal and alcohol and nicotine were. Well, I'm here to tell you, actually I'm not, this lovely group is here to tell you, nicotine is the gateway drug. It increases and enhances administration of all of those, which, if you want to put in real world terms, means if you have exposure to nicotine, and this is not simultaneous exposure. These were rats who smoked, quote unquote smoked. They had exposure to nicotine, they were given nicotine, but analogous to us smoking as young teens, then they, were at a party and they tried cocaine for the first time, they're much more likely to do it if they had exposure to nicotine when they were younger. So nicotine is changing their brain so that when they do experience some of those other things, they're more likely to have problems with it. They're more likely to get a response from it. They're more likely to have problems with addiction. We don't really talk about addiction necessarily in the rat. We call it self-administration. Are they more likely to administer? Do they do it faster? But that's kind of analogous to trying it that one time and liking it enough to try it again, and that movement from that single use to repeated use. So the effects of smoking and smoking abstinence on cognition in adolescent tobacco smokers. So now we've moved from the rat back into the human. So we have adolescent smokers, average age of 17, and non-smokers, average age of 16.6, so they're pretty well matched. To be a smoker in this study, onset, you had to smoke daily, and they had to be 24 hours abstinent when we did the collection. Because once again, we don't want to see the body in immediate withdrawal, and we don't want to have the drug on board when we're doing the testing. Interesting is the average age of onset was 13 for this group. So they did two different types of testing. They did a Hopkins verbal learning test, and essentially what that means is they give them 12 words, and then 3 minutes later they ask them to tell them the 12 words, and they do it. They give them the 12 words again. 3 minutes later they ask them to do it, and then 25 minutes later, after a longer 25-minute delay, they ask them to tell them the words without being prompted. What were those 12 words I told you? And then immediately following that, they give them a list of 24 words, and you have to pick the 12 from the original list out of them. So that's kind of verbal learning. They did a two-back, which essentially is hearing nonsense words. So it's not words that are tied to anything. They're kind of these nonsense words. Gruff, and I can't remember what the other one is. They gave some examples. They're kind of nonsense words. So they're not things that you would traditionally think or hear, so you can't make, like if you hear farm, cat, dog, you're like, oh, I can grump those together and try to remember them. They also heard some tones, and this was in both ears, so they heard it in both ears, and then they had a match. Did what they heard on this trial match what they heard 2 words ago? So if I say cat, dog, cat, yes, that's a match, because cat and cat match. But if I say cat, dog, dog, it's not a match, because dog and cat don't match. So that's what they had to do for this particular trial, just to give you kind of an idea. Here's what we have for nicotine. These are our smokers, and these are our non-smokers. And these are neurocognitive tests. This is a brain function. This is how your brain is functioning, how you are functioning. If you are a smoker, and smoking at least 1 cigarette a day. There's a huge increase. Hold on. There we go. Okay, there's a huge increase in the amount of time it takes them to be able to do the recall. So your processing is slowed down when nicotine is on. Okay. And then over here is the two-back. So what we see is that there's faster response rate. There's more faster response rate in these types of tests indicate a better understanding, like you remember it better. Because if you don't remember it at all, it gets coded as a higher amount. Does that make sense? Oops, sorry. So we see that the people who are the smokers have a reduced sensation from the non-smokers. So when you're not smoking, you're much better able to do these types of tasks if you've never had smoking than if you have. It also shows that when you've stopped smoking and you're abstinent of smoking, that you can recover, or that when you stop smoking, you actually don't see a recovery. Because this is our non-smokers up here. So when you're not smoking, you don't see recovery. You don't see it getting better. In fact, it gets a little bit worse, most likely because of withdrawal symptoms. Okay. So this is a big table, and I don't love it, but I couldn't find a really good graph. But it is a lot of really interesting information about cannabis. So marijuana is a big hot topic right now because we're in many states deciding, should we let marijuana be legal? There are political ramifications, there are financial ramifications, and then there are actual health ramifications of that. And they're very different topics. And I'm not going to deal with any of the first two. What we're going to talk about is the effect of adolescents' brains on cannabis. Because even if cannabis is legal, it's not legal to adolescents. Okay, so neuropsychological, neuroanatomical, neurotransmitter. We see decreased, what you can see here very quickly, neuropsychological is all decreased. Decreased verbal learning, decreased psychomotor attention, storing memory, decreased performance in attention and memory testing. So these are all different papers that you can kind of pull out and look at. But essentially what this is showing is paper after paper after paper is showing decreases in neurophysiological responses for those people who've used, for those adolescents who've used cannabis. There's increased cortices in the cortex, so decreased hippocampal volumes, decreased gray matter. So if you remember, the hippocampus is part of our limbic system, right? It's part of our reward emotion regulation system. So not having as much volume there is important. Interesting about marijuana is that there are parts of the brain, and this particularly is a little bit more prominent in females. There are differences in how the response in the brain between males and females. Not that they do different things, but the rates are a little bit different. In females, they see increases in these cortices thickness, which essentially means the brain's job of pruning. So during adolescence, especially in early childhood, but all the way through adolescence, the way the brain develops is it produces new connections. So neuron A talks to neuron B. And it also talks to neuron C, whatever. And neuron A and C may have this great connection that's helping you learn trigonometry. And neuron A to B maybe was used for something that wasn't super helpful, like, I don't know, something you don't need anymore. So your brain's job is to go in and say, okay, this connection is not super helpful, we don't need it. We need to clear out some of the connections that we don't need. That's how the brain stays healthy, it's how it develops and matures. So that's an incredibly important process. It's called neuronal pruning. It happens when you sleep. So as adolescents, that's a big process that's going on. So getting sleep is really important. I'm just going to throw that tagline in, even though it's not part of our topic. But neuronal pruning happens during sleep. So what we're seeing, particularly in females, it's much higher in females, is that there's a loss of this neuronal pruning in part of the cortices. Parts of the brain that help with function and thinking aren't pruning and responding quickly. And it correlates very tightly with increases levels of depression because there's more of these connections, there's more of these cells, so there's more triggering and it tends to end up causing more depression. Gray matter, so we talked about the white and the gray matter a little bit. there's decreased gray matter volume in the amygdala, prefrontal cortex, parietal cortex, and striatum. So some of these words are very familiar. The gray matter, that's the actual part of the neurons that are signaling. That's our cell bodies. That's telling us that there's death of the actual neuron, that these neurons are not, there's not as many of them. In the part of the brain that's doing all the activity, that's doing all the connections, doing all the thinking. The white matter part of the brain, not that it's not important, is just essentially information transmission. The gray matter is where all of the processes are happening. So having a decrease in the amygdala, which is responsible for emotions, in the prefrontal cortex, which is responsible for regulation, is not a good thing. We also don't know, at this point, there's not a lot of data to suggest the long-term effects of that. Does it get better if you stop? So there's still a big question out there, and this is an important one because we don't have good answers right now, is if you did drugs and then you stopped, can we recover this? Part of that is depending on how long it takes you to stop. If you stop after your brain has gone through this process and is kind of done doing the maturation process, it's much harder for your brain to fix that than if you stopped while your brain was still developing and these processes were still going on normally. But we don't know still how that's affecting it. So these may very well be, and a lot of people think they are, long-term changes. So what you do as an adolescent may long-term affect your brain's function. So it's important to remember that. All right. So it's not all bad yet, but we don't know. So this slide, I don't want to put this slide up and people are like, oh, this is good. If I'm going to use alcohol, I should just make sure I use marijuana too, and it'll protect my brain. But this is actual data, it is true. But the question comes out, is marijuana protective? Is it protecting this alcohol reduction? Maybe. It might be. We don't know enough about it. But also, it's very possible that teens who regularly use these have different cortical thicknesses ahead of time. And this is one of the things I was talking about with where ABCD is coming from. This is one of the questions that we ask. Because every once in a while, we'll see this. We'll see that it appears that their volumes, their volumes are getting smaller, but there's more of them. Is something happening in the beginning? When they first started using drugs, is it causing an increase in volume, and now we see that reducing? Or are people who tend to use drugs and get to this point have larger volumes to start with? And we don't have the answer to that. That's one of the questions that came into putting together the ABCD study, is what does everybody look like in the beginning so we can know really what's happening? There is still a lot for us to learn. And we now have studies, ABCD isn't the only one, there's also the Incanda study, where we're looking long-term and trying to look before the onset of problems so we can answer some of these questions. Okay, so wrap up. I got 3 kind of quick wrap-up slides. Parents are lame and uncool. I am a mom. I will tell you we are lame and uncool. I don't want it to be about how cool or not cool we are. It needs to be about discussion about facts. What's really happening? Nicotine, alcohol, and increasingly marijuana are commonplace. Make sure that your teens or you guys know what's going on in your brain and how these things affect it. Because as things become more commonplace, as we see more people smoking, as we see more people drinking, as marijuana becomes more public, it's very easy to forget that there might be a problem with that. It might be dangerous because we see it all the time. So we need to take away that familiarity and remember that there's something really going on here. Using drugs and alcohol has a greater effect on the adolescent brain than it does on the adult brain. It does, because the brain is maturing. So we need to remember that. Every child thinks it will never happen to them. Rate addictions are higher in the younger you start. So people who started using it like 10 or 11, much more likely to have an addiction problem than people who started or sampled or tried when they were 25 or 30. Okay. Addiction has a genetic component. If there is a family history, it's important to know that and talk about it. Because you may just be that, every kid is, it's not me. That would never happen to me. I'll just use it once and I'll stop. But if you have a genetic component, that once might be enough for your child. Okay. Wrap up, kind of coaching hints. Talk to your child about your family drug and alcohol policy. So not just, hey, don't use drugs. But in our house, we don't use drugs because you're not, we don't allow you to use consume alcohol until you're 21. We don't use tobacco because. But make sure you have a firm policy. You've actually talked about it. Make multiple conversations. This is not a one-time, hey guys, I just learned tonight that your brain is really bad if you use drugs and alcohol. Don't do it, and we all move on, and we never talk about it again. It needs to be a repeated conversation, and it's best done naturally. So if you're traveling to Colorado, which is not that far from here, and you can, hey, they have marijuana recreationally available. Adults can go buy it. What do you think about that? What do you know? I heard a story today that scared me very deeply, is that there was a school talking to the kids about drug and alcohol, and some of the information they were giving was just not correct. So talk to your kids about the information they have, because if they got it from their friends, it may not be correct. Even if they got it at school, some of the information may not be correct, or they may not have understood the conversation correctly. You know, a lot of times kids pick up, I know with especially our little kids, I tell them that the neurons, the myelin sheathing, is like the plastic covering of your wire and your Apple cords. The kids go home and say they have Apple cords in their brains, because that's what they hear and that's what they remember. So it's important to make sure that the message they're hearing is correct. There are lots of websites, and I actually have a slide of some pieces to find information. Teens.drugabuse.gov is NIDA's teen page. It's a great place to go get accurate information. There's little games you can do there. There's little quizzes. There's information about how the brain functions. Some of the pictures I took are actually from that website, showing you how the brain works and how this functions. Never talk to your child while they're under the influence. If they come home and they've been drinking, or you find them, you know, that they were smoking pot or doing something else, that is not the time to sit down and be like, we're going to have a discussion about how bad drugs are for you. They're not processing that. They need to be in a calm place. They need to not be under the influence. You need to be in a calm place so that you can have an actual useful discussion about drugs and alcohol, and not a screaming match that they're not comprehending and taking in. Remember, when they're under the influence, their brain is not functioning. Their learning memory, their auditory recall, all lower. It's not the time you want to tell them something. They're not going to remember it. Or they're not going to remember it accurately. Okay, if you know your teen is using or has a problem, get help. We have low rate of getting help here. I mean, it's pretty low. But it's still not, okay. You want to make sure that you're getting help for those that need it. We're not statistically different from the rest of the country, but this is the number of kids, teenagers, who did not receive treatment for alcohol or drug use during the 12 months before the survey. So these are kids who needed it or were seeking it and didn't get it. So make sure if your kids are having problems that you get the help you need. These are some resources. NIDA has some great websites, drugabuse.gov, teens.drugabuse.gov, the Oklahoma Department of Mental Health and Substance Abuse Services. This is where some of the reports that I showed tonight came from. DARE is still around. It was funny, I was drinking out of my water bottle and I realized it's from my kids' school. It's from their DARE program, from my kids' school. But DARE is still around, and it does have some useful resources on there about the brain, how the brain works, what we know about adolescent use and the brain. There's a lot of other stuff in there too, but there is some stuff there as well. Questions and ideas. I'm more than happy to take questions. If you have any ideas, things you want us to talk about, we can cover that. Information of how to contact us. The next Healthy Brains is April 27th. It'll be Dr. Martin Paulus. It's going to be an ABCD update. So ABCD kind of supports the Healthy Brains for Healthy Oklahoma series. So this talk is going to be, what have we done so far as part of this study? What do we know? What have we learned? What does recruitment look like? Who's involved in it? Things like that. You're all more than welcome to attend. And before I take questions, I'll just throw a pitch out because we do have a whole bunch of high school students. ABCD, as a research program, does offer an internship. We will allow high schoolers to do internship. We can do it for volunteer community service hours if that's something you do. You can come and work with us and learn how research works. You can become part of doing research. So if you're interested in science or you want to learn about this more, we're always happy to take in students who are interested and willing to work to come into our program and participate with us. But otherwise, I will just take some questions if anybody has any. Yeah? Well, it's different. Okay, so the question is the genetic components of addiction. So genetic components of addiction are not super well understood. And there's a lot of mixing because families where addiction is more prevalent, there's more exposure, and there's an actual DNA genetic component. And teasing those out has been a struggle for a long time. So there is still work that needs to be done. But there are genetic components where you're more likely to have a heightened response from the increase in dopamine signaling than somebody else. So when you look at addiction, particularly addiction more than initial response, it's caused by this repeated exposure and increase in dopamine signaling. Some people will have a heightened response to it. They'll see more signaling. The feedback loop is stronger, and it causes more signaling, which puts them at a higher risk for addiction. There's also a family kind of dynamic where the more exposure, there's higher levels. That's not actual true genetics, but it's hard to tease out because those commonly run together. That is an area we need a lot more work on. We need to look into more. There is some information about actually family history and genetic components of addiction available online you can kind of look into, but there's still a lot of questions there, so just be careful about any firm, this is the problem, this is the solution information. Somebody else is going to ask a question. Yeah?
Okay, so in countries that have lower disease ages, 18 to 60, are they facing the same brain development problems? And if so, what steps are they taking?
That's a really interesting question. So I will tell you two things right off the bat is I don't study, I have not researched addiction levels in other countries very much. So what I do know, and I have kind of heard, the US tends to have a higher rate than a lot of other countries. Some people attribute that to controlled exposure, where people have, it's not a taboo thing that all of a sudden I'm away from my parents and I'm going to go try, or I'm using it as a way to rebel if there's more exposure to it. But the US tends to have higher rates of this. That may not necessarily be, though, just due, that is not, the idea that we're not exposing our kids or there isn't controlled exposure here is not the reason behind that. There's other things as part of our societal component, how society is made up here, that tend to put us higher than other places. Now, there are some countries that do have higher rates of alcohol addiction or other things, but the US tends to be pretty high on all those scales. So it's definitely something to look into. I actually don't know that much. I haven't researched it all that much. But I do know that we are pretty high on the curve. Same thing with things like obesity. General unhealthy behaviors tend to be more prevalent in this country, and alcohol and drug use fall right into that unhealthy behaviors category.
Also, with the legalization of marijuana, or with recreational marijuana, is that helping our society? Because I know there's economic benefits to it, but is it really hurting us by legalizing it?
So there's an interesting conversation that's going on right now, and this is a big conversation in ABCD, is what do changes in exposure do to usage? How does it, and it's interesting because we're having this same conversation in Oklahoma right now with alcohol, right? Lots of states have alcohol in the grocery store. It's more accessible. Traditionally, Oklahoma is not, and people who were very against that bill passing in the last election, that was their complaint. It's going to be too much exposure for our kids. It's too easy to get if it's just in the grocery store. They always see it. Other states don't see as many problems. So is it because those states don't have as many problems, their population is different, or is it because it doesn't actually cause a problem? We don't know. But interestingly, is in ABCD, we've already started looking at kids. We have 200 kids enrolled. Most of them will be through their baseline before the law that we just passed goes into effect. Same thing with legalization of marijuana. We have sites in different parts of the country where legalization of marijuana is now passed, but it's not actually in, the law passes now and it becomes effective like a year from now or whatever. So we'll have a bunch of kids in different sites who we can watch that transition. We know what the baseline looked at when there was less exposure. Now let's see, does it really change rates in that same population? Because right now we look across and we say, well, Missouri doesn't have higher rates than Oklahoma of alcohol consumption, but alcohol's in the grocery store. You can buy it in CVS. So it must be that it's not a big deal. Well, maybe. Or maybe there's lower predominance rates of alcohol use and abuse in Missouri, so the population is different. And if we look at the same population in Oklahoma and we change the access, we'll actually see an increase. That's not usually done. We don't have a lot of data that shows the start and the stop. Colorado is collecting this information. They're starting to look at it now because they've had it for a few years, is do they see increases in rates in teens and adolescents because there's more exposure? But it's new. It became legal in 2012. So we are still at the very cusp. You have to have the before and you have to have a little while the after to be able to make those decisions. So this is a question that we're answering right now, that we're asking and answering right now, and we need to see where the data leads us. So we can really finally answer that question. So that's a very interesting conversation we actually had right before this talk. And the question is, essentially, is controlled environment, what are the effects of that? Are kids more likely, less likely to use? And it's interesting because there's two kind of conundrums there. That is a question that a lot of people don't want to ask and answer. Because the rule is we're not supposed to give kids drugs and alcohol. So do we want saying, all right, actually it's better if at home they have a sip with mom, or it's not as a taboo subject, is that better? So that leads to the question is, we're not 100% sure yet. There is a lot of evidence that suggests that if it is an open conversation, it is not a taboo, we just don't do it, it doesn't exist, we shouldn't talk about it, you should never do it. But open conversations, exposure, letting them see it in a controlled environment, whether that means letting them try a drink at home. It's hard too because alcohol is a little bit different. Probably are going to drink alcohol at some point during their life, but you want to, when does that start? What does it look like? Because we don't obviously want alcohol addiction or alcohol abuse versus occasional alcohol use. It's different with things like nicotine, with marijuana, with, of course, harder core drugs. You really want to prevent use at all, right? Recreational marijuana, not interested in getting into political, social conversation, but in adults, good, bad, it's kind of hard to say yet. We're still kind of in the new area. Is it really a harder core drug, or should it be lumped down in with alcohol? And that's kind of, I'm not comfortable making that decision either way at this point. I don't think most of us are. But nicotine outside of the brain, and we talked about the effects of the brain, has a ton of health risks associated with it. If you're smoking, you've got lung cancer, you've got the effects of chewing tobacco, oral cancer. Those are just minimal side effects. Emphysema, there are lots of side effects. The other effect of a lot of those drugs is the effect of the innocent bystander. So, of course, one of the huge problems with smoking is if you and I smoke, well, maybe it's not affecting our brain so much. We know there's some health consequences. But whoever the kid in our home is exposed to it, and we know it's affecting their brain. So there are other kind of layers to it. So those are a little bit harder. The idea of we should know why we shouldn't do this, but we really want to stay away from ever using is probably a better way to go. Alcohol is a little bit harder because there probably will be some kind of alcohol use for most people during their adult life. So do you let them have a sip or not? I'm not going to tell anybody they should let their kids have a sip of alcohol or not have a sip of alcohol. But I think that making sure the conversation is open, talking to them about it, and how you decide to handle that as an individual family is much better than just say no. Just don't do it. Just never try it. Because that's not realistic and it's not going to happen. Does that kind of answer your question? Okay. Go ahead.
Would regulating the THC levels of marijuana
Well, any amount of THC is going to have some effects. Part of the problem we have with the research we're doing now is that we have no idea how much THC any one person is using for the most part. Regulation makes it better for research because then we can say, oh, you went to the store and you got this joint, that's 5 milligrams of THC, now we can compare it. Right now it's completely unregulated, so we just don't know. That doesn't mean that there are differences in health effects or rates of addiction or problems from being under the influence. It just means that it would be easier for us to study. It's just really hard right now to answer those questions because we could have somebody come in and say, I got a joint. And it was, even we know the amount, like it was 2 grams. Depending on the breed of the plant, where they got it, anything else that was done to it, it can dramatically change the THC content. So it makes it hard to do comparison. And it makes data kind of messy because some of these people may be using a lot more THC than others, but we kind of lump them all together because we don't know. So as a scientist, I think regulation is great because then we can know, hey, they smoked a joint that was 5 grams of THC and they ate a brownie and that was 6 grams, but we just don't know yet on those effects, partially because it's very hard to regulate exactly how much. And we're never going to do the study where we bring in a bunch of adolescents and say, this is a joint with 5 milligrams of THC. Let's see how that's different from 3 milligrams of THC. Synthetics are horrible, horrible. Synthetics are bad for lots of reasons. One is you have no idea how they were made and what else is in them. And more importantly, it's not so much, we used to talk about this, like cocaine on the streets. I worked in a fruit fly cocaine lab when I was in grad school. And my boss used to do demonstrations, and you'd give a little bit of the cocaine to the fruit flies, and you could see the behaviors. And one time he got a small sample from a drug from the police that they had obtained from somebody who had it illegally. And he gave it to the fruit flies in the exact same quantity, and they all died instantly because it's not the same, and there's a lot of stuff in it. But what's even worse with synthetics is that because you don't know exact chemical makeup, some of the chemicals can be interacting with each other, causing even more problems. We just don't know. So that's bad. Drugs in general are bad because a lot of that can happen. You can have, if you obtain drugs from someone, they can be cut, they can be mixed with something else that you may or may not know about. If you want to call it a benefit, the one kind of benefit of the commercial business is that there's a lot more, at least, detailing of that. This is, a mixture. This is true just from this plant. This is this breed of plant. We can at least get that kind of information. Most users don't know that level of detail, but at least the consumer has a little bit more information. Go ahead. So the question is about vaping. That is a new big hot topic that I really should have looked into more before this talk, but I ran out of time. We used to think vaping was it was a safer, the e-cigarettes came out, vaping came out. These were better alternatives to tobacco cigarettes. I'm not here to tell you that's not necessarily untrue, but there's a lot coming out that is not as good as we thought. There are other effects. Vaping comes into this kind of synthetic idea that Dr. Morris just brought up, is that what are we mixing in? Because it's not just pure nicotine, right? We're not just putting pure nicotine in or whatever you're using. You start to get mixing effects, and we need to look at the chemical compounds that are all mixing together and see how they're affecting the brain. Because the one thing to remember is the brain is a chemical system. So if you have multiple chemicals, it may not be acting the way you think it is. They could be interacting with each other, and you could be having a less effect, not probably likely because people wouldn't keep doing it. They could be enhancing the effect. You could have one chemical that's signaling the dopamine receptors, the other one's blocking the receptors. I mean, you could have all sorts of you could be affecting dopamine and serotonin and norepinephrine, which is another one. You could be affecting acetylcholine, all these different proteins at the same time. So there's a lot of that going on, but there's definitely a lot of research coming out now that vaping is not as health friendly as we thought it was. And that's both health-wise and in the brain. It is not as good for you. And I think the strong take-home point here has to be, particularly, I don't recommend people use drugs, smoke, vape, ever in their lives. But in the adolescent time, because your brain is changing so much, there is so much going on for the normal function and development of the brain, anytime you put in an outside chemical, you are affecting that. And that's true. I mean, we give kids prescriptions all the time, and I don't think people should not take their prescriptions. But I do think that we should be aware of exactly what we're doing and how it's affecting the brain. If you have a kid who needs a medication, like an ADHD medication, then the effect on the brain and these neurotransmitters is in a positive way, right? It wasn't functioning normally or how it should have been, and now we're giving this medication to help the effect. Anytime you put in a foreign substance, you're getting the other effect. You're getting an effect of this is how it's supposed to be functioning, and now we're altering that. And any kind of alteration to a developing system is not good for it, because it affects its endpoint and where it can get there. And this data shows it. It's decreasing size, it's affecting the learning and memory, so the function of those neurotransmitters. Anybody else? All right. Thank you all for coming. It's hard because it's kind of like, hey, this is how you start the kids. I'm like,